This is a lesson for 4.2, which is on the greatest common factor. Before we begin, there's a few vocabulary words we should know for this section in order to make it easier to solve the problem. So the first is a common factor, and it states that a common factor is a whole number that is a factor of two or more non-zero whole numbers. So an example of this could be 6 and 9, where 6 factors are 2 times 3, and 9 is 3 times 3. So they both have 3 in common. So a common factor for 6 and 9 is 3. The greatest common factor is the greatest whole number that is a factor of 2 or more non-zero whole numbers. So basically what this means, if we had 20 and 10, 20 is going to be, you can have 1 as a factor, 2, 4, 5, 10, and 20 are all factors of 20. And for 1, we have 1, 2, 5, and 10. So the greatest common factor of these two, even though they share 2 and they share 5, the greatest is going to be 10 here, because they're both sharing 10. Sorry, that's a bit sloppy. So the greatest is just talking about that greatest or whole number that is a factor for both of those, at least 2 or more non-zero whole numbers. Relatively prime is when 2 or more numbers are relatively prime if their greatest common factor is 1. So for example, if you had 5 and 3, you have 1, 5, 1, 3. Their greatest common factor is 1. So these are relatively prime. In this case, 20 and 10, they're not relatively prime because 10 is the greatest common factor. All numbers at least have 1 as their GCF. So if nothing else in common, they always have 1 as their greatest common factor, and they're relatively prime. So let's go into some example problems. So the first is, how do we find the greatest common factor? Well, there's 2 methods, and I already hinted at them a little bit on the previous page. The first method is to list the factors of each number and identify the greatest number of that on every list. So in this case, if we wanted to find the greatest common factor of 75, 60, 30, and 45, what we could do is first list out all of the factors for each. So let me see if I can get this to work. I think I'll just have to circle it. So in this case, we list out all the factors of 75, all the factors of 60, all for 30, all for 45, and then we look for the greatest number they all have in common. So in this case, 25, nope, 15, yes, 15 shows up on all of them, and no number greater shows up on all of them. So our greatest common factor, or GCF, equals 15. Other ones that they have in common, which are common factors but not the greatest common factors, include 5, 3, and 1. I'm not going to circle them all. All of those are common factors, but the greatest one is 15. So that's method 1. Method 2 is actually the one that I prefer to use, but you're welcome to use either, is to write the prime factorization. So using that tree, or sometimes some of you may have developed a method for doing it without the tree. So then we multiply all the common prime numbers. So in this case, 75 would be 3 times 5 times 5. 60 is 2 times 2 times 3 times 5. 30 is 2 times 3 times 5. And 45 is 3 times 3 times 5. So all of those are prime numbers. And then what we can do, Let me get a little finer marker here. It might not be an option. Let's see. So here we can then look for what do they all have in common. That's fine. So they all have a 5 in common, and they all have a 3. Now you can only use each number once, so that's why I'm circling them like this. So for the greatest common factor, the only thing we need to do is 3 times 5, because they all have a 3 in common and they all have a 5 in common, which is 15. So our GCF is 15. So this is just multiplying those in common. Now if it was a 2, that's not, because it's only these two numbers. That needs to be for all of the numbers. So what I'd like you to do is find the GCF of the following numbers. I'd like you to try for the first one using method 1, the second one use method 2, and the third use the method of your choice. So whatever works best for you. So try method 1 first, then method 2, then your choice. Press pause now and work on these problems. The second example is how can we identify those relatively prime numbers. So in this case, we're going to do A and B, two examples, and we'll use a little bit of we'll use one of the two methods from the previous slide when finding the GCF. Now remember, numbers are relatively prime if their GCF is equal to 1. If it's greater than 1, then they're not relatively prime. So the first thing, list the factors of each number and identify the greatest in the list. So if we had 19 and 57, in this case, they both have a 19 as their GCF. So this is greater than 1. So they are not relatively prime. Let's try the other two. This time I'm going to use the prime factorization. So if we had 16, it's 2 times 2 times 2 times 2, which is the same as 2 to the 4th. You can write it either way. And 81 is 3 times 3 times 3 times 3, 3 to the 4th. There's no common prime factors. However, they always have 1 in common. So 1 times 16 is going to equal 16, and 1 times 81 is going to equal 81. So the greatest common factor is 1, so they are relatively prime. So whenever the GCF is 1, they're relatively prime. Anytime it's greater than 1, they are not relatively prime. So I want you to find the GCF of the numbers here and then say whether it's relatively prime or not relatively prime. So stop here and try these problems before continuing on. And the last example is, what if we have those monomials again? So what if we have variables in these equations? So if we had 21x squared y to the 4th and 33x to the 3rd y squared, how could we factor these monomials and find the GCF? So in this case, we can write 121 times 121, or 121 is 11 times 11, 2x's, 4 y's, 33 is 3 times 11, 3 x's, 2 y's, and we use the same thing that we used in the previous method, the second method. We see what they share. So in this case, we have an 11 in common, we have 2 x's in common, and 2 y's in common. So our GCF would be 11 times x times y times y, which then can simplify to 11x squared y squared. So that would be the GCF of these two terms. So what I want you to do now is to try the following two sets to find the GCF of 300ab squared, 125a squared b, and then do the same thing for 12xy and 18x. So this is the end of the lesson today. Try these problems and bring them with you to class. And also jot down any questions you may have on this lesson.